In this lecture, we will be learning about the searching algorithm in array. So searching means you want to search any element, whether that element is present inside the array or not present inside the array. So if you see in this example, so input will be array of an element and you want to find an element x. So you want to find whether x is present. If x is present, then you will return the position or index of x. If it is not present, then you will return -1 or you may print element not found kind of message. So suppose this one is my array and in this array total number of element is 9. So if you want to search individual element like 11 here, so it will start searching from the 0th index and it will go up to the end, searching up to the end of the element. So here if you see this example, so here total number of element is, you can say, if you just want to write down the index positions, this one is 0, 1, 2, 3, 4, 5, 6, 7 and 8. So you want to search 11. So my element or data I want to search as 11. So it will run a loop, it will run a for loop from 0th index up to the element where the data is found. Or if data is not found, it will search till the end, and if it is not found, then it will return it is not found. So if you just want to check the algorithm, so it is something like this. If you want to perform linear search, there are two ways to search in the list. First one is linearly. You can go linearly and you can go to search each and every element one by one. And the other type of search is binary search. I'll discuss later. So if you want to perform linear search operation, you will make a function named as linear search, and here you will pass the array name and what is the size of the array and what is the data you want to search. So you will run a for loop from 0th index up to the n or n-1 you can call, till that time loop will run. So if element at 0th position, so if you just want to give an example, suppose there's an element is like 10, 5, 20, 7, 8, 9, 6, something like that. Total number of element is 7. So loop will run from 0 and will go less than, if you are making a equality condition here, then it will go up to less than equal to n-1. If you are making less than condition, then it will go up to n. So it will check whether the, and if I want to search data as 9 here. So it will go and will search the first element a0 equal to 9. Yes, then it will return the ith position, that is the index of 0. Right, this one is the basic thing, right? But if you found the element and you don't want to search all the element present in the element, you don't want to traverse all the element in the array, then what you will do, you can, if you are finding the element, then you can break from here and you can go out from this loop. After going through the complete loop, if you are not getting the element, then you will return -1. That will symbolize that your element is not found. Or you can make a flag variable here also. So if you are finding an element, you will set the flag bit as 1. If the flag bit is not set as 1, then you will check whether the flag bit is 0. Then you can say the element is not found. So for each type of, we just want to check what is the best case complexity and worst case complexity. So best case complexity will be if you want to search the element and that is the first element that you wanted to search, so you need not to do traverse the complete array here. You can find the element at the first position, so you can call it best case complexity is big O of 1, because in only one iteration you are getting the element. Suppose your element that you wanted to search is at the last position, then you can call the worst case, when because you are getting the element at the end, so you can call you need to traverse the element till big O of n. And if you are searching till the end and you are not getting the element or element is not found, still you need to search till n times. So best case complexity is big O of 1 and worst case complexity is big O of n. So that is about linear search. Now I just want to move to the binary search. So in the case of linear search, when I discussed about the linear search, in the linear search, the element that was present in the array was not sorted. Sorted means they were not in the ordered manner. But if you talk about the binary search, in that case, the array element should be in the sorted order, either in ascending order or in descending order. And then if you want to find the element, it will find the element and it will return the position of the element, or it will return -1 if it is not found in the you can say array. So here you can see the array, and if I want to find 40 that is present inside the array, how it will work, that is shown here. So I just want to discuss few things before starting the algorithm part of the binary search algorithm. I just want to discuss about the working principle of this binary search algorithm. So the binary search algorithm is working on divide and conquer rule. Means this array will be divided into two parts, then it will be further recursively divide itself into two parts until and unless you are finding the element or your array is exhausted. So suppose I'm just taking one example of an array and the element of the array is 6, 8, 10 because the element is sorted. So I'm just taking element something like this. So I'm taking element like this. So in this case, there are three kind of variable we can declare. First one is left variable, second one is right variable, and third one is mid variable. So these three things we need to define: left, mid, and right. So if I just want to discuss in detail, so I'm just writing here the element again, 6, so I'm writing it 6, 8, 10, and then 11, and then 17, 19, and then 20. So index is 0, 1, 2, 3, 4, 5, and 6. So left is this one, and this one will change recursively. Right is this one, and mid I need to calculate. So mid value will be left plus right divided by 2, and this one will be the floor value, not the ceiling value, because we are doing integer division. So in integer division we are getting the floor value always, right? So in the first case, when I want to search, suppose I want the data I want to search is 19 again. So my data is 19 and number of element is 7 here, right? So I want to search 19. Okay, so in the first case, if I just make a table here of left, right, and mid. So the position of left is 0, the position of right is 6, index if you call 0 plus 6 by 2, that is 0 plus 6 floor division by 2, that will give you 3. So in the mid position it will go to 3. So here this one will be mid in the first case, right? So now you will search. There will be condition. You will search, you will check your data is present in the left half, right half, or mid case. There will be three cases. If data is equal to array of mid, then you can say element is found. If your data is less than mid, then it will go and perform binary search in the this half. And again it will, if it is greater than mid, then data will be searched in the right half. So like that it works. So we have seen now data is 90, that is not present in the left half, it is present in the right half. Now how left and right will be updated? So if it is present in the right half, then right will not be updated, right will remain same here, left will be updated. The value of left will be mid plus 1. So here mid is 3, so it will become mid plus 1, that is 4. So 4, and if you do the division, 4 plus 6 by 2, and if you just want to do a floor division here, you can see the value I am getting as mid is 5. Now what is happening? Now my left is this one, right is this one, and mid is this one. Now if you see 19, so data is equal to a of mid. That means I'm finding my data here. Now I'll return the index, nothing else. If it is again not found and left equal to right and your data is not found, then you will return -1. So if you just want to see the algorithm part, so you can see here, if I, here you can see this one is the array, I is the left, j is the right, x is the item you want to search. If I equal to j, means you can say you are coming to a point where there is nothing left, nothing right. You have traversed the complete array. And if you are getting the element I as the data x, then you will return I, that is the index of the data. Else you will return -1. If this one is not the condition, when there is some element in the left side, there is some element in the right side, then you will take the mid. And if mid equal to array mid equal to x, you will return mid, like I discussed in the previous example. If array mid is greater than x, that means data is present in the left hand side. So if data is present in the left hand side, then what I can do, the if so I write like this: left, mid, and right. So if data is present this side, so my right will be updated as mid -1, left will remain same. So left will remain same as I, but right will become mid -1, and x will remain same because the data we wanted to search is same. If the data is present in the right hand side, then my left will become mid +1, right will become j, that is the right here, and x will remain the same. So like that you can say here we will use binary search to search any element in the array. Now what will be the complexity for this particular binary search? So here the complexity will be log n time, right? So when you are dividing any array or anything, when your loop is running in such a way, when suppose I'm just writing I equal to 1, and in place of I plus plus, I'm just writing I cross 2, or if I'm writing I by 2, in that case the loop is running not n times, the loop is running log n times, right? So you can write like this. Suppose I just want to run a loop until 1 to 100. So value of n is 100. So if I'm just doing so if I just my value of n is 100 and I want to decrement the value by 1 each time. So first time the value of I will be 100, then 50, then 25, then 12, then 6, then 3, then 1. So how many times this loop will run? Because I'm just doing I by 2 each time. So 3, 3, 6 plus 1, 7. So if you will write log 10 base 2, that will be approx floor value ceiling value of this one, that will be approximately 7. So you can call here in this case also, if you are performing binary search operation, in best case and in worst case, it will give you log n time complexity. So that is it about the binary search operation and linear search operation. So you can call here binary search is better in terms of complexity with related to linear search, because it is taking less amount of time in comparison to linear search. That is it about search operation.